T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Engines full power. And liftoff. Go Bandwagon, go ADD 425.
Vehicle is pitching downrange.
M1T chamber pressure is nominal.
Falcon 9 has lifted off from Space Launch Complex 40 at Cape Canaveral Space Force Station. We're currently throttling down to prepare for max Q, the point of maximum aerodynamic stresses on the vehicle. Max Q occurs in the lower atmosphere, where there's still enough air to create significant resistance
and telemetry nominal
against the rocket. This is when the pressure pushing against the rocket is at its highest point, and it's a key test of the vehicle's structural integrity.
Falcon 9 is supersonic.
After max Q, the rocket continues to accelerate, but the air becomes thinner, reducing the stress on the vehicle as it climbs through the upper layers of the atmosphere.
Max Q.
And there's the call-up for max Q. Merlin engines are back at full power, and we're out of the throttle bucket. From here on, even though velocity is rapidly increasing, the atmospheric density is decreasing, resulting in less loads on Falcon 9. Now we have several events coming up in quick succession, starting with MECO, followed by stage separation,
and back 2.
stage 1 flip, second engine start 1 or SES1, and the start of the boost back burn. Main engine cutoff, or MECO, is where all 9 Merlin 1D engines shut down to slow the vehicle down in preparation for stage separation, where the first stage separates from the second stage. Following that, the Falcon 9
trajectory is nominal.
The Falcon 9 first stage will then perform a flip maneuver as the MVAC engine on the second stage is in startup. Then we'll see the start of the boost back burn on the Falcon 9 first stage, followed by fairing separation, where the fairing will jettison from the second stage, now that it's no longer needed to protect the payload once we're in space. And at our customer's request, we will not be showing fairing separation today.
Stage separation confirmed. Stage 1 boost back startup. And back startup. Fairing separation confirmed.
And there we heard those events that happened back to back: main engine cutoff, stage separation, stage 1 flip, second engine start 1, the start of the boost back burn on the first stage, and fairing separation. We should expect the end of the boost back burn shortly. The next major milestone coming up is the entry burn on our first stage, scheduled to occur at about T+5 minutes and 56 seconds. Falcon 9 will perform 2 more burns in order to land. The first of the 2 burns is
nominal trajectories.
The entry burn to slow itself down before hitting the denser parts of Earth's atmosphere. It's similar to pumping the brakes on your car. Without this burn, we'd only be using the atmospheric drag alone to slow down Falcon 9, which adds extra stresses on the rocket. The Merlin 1D engine will relight for that entry burn, and following the entry burn, the booster will go through its final burn, the landing burn, which should slow the vehicle down even more for a successful land landing. You'll notice the number 4 in today's mission name, indicating that this mission is our 4th dedicated rideshare mission to a mid-inclination orbit. Rideshare significantly increases access to space for small satellite operators around the world. While our transporter rideshare missions launch to a sun-synchronous orbit, bandwagon missions can accommodate even more small sats looking for rides to orbit, launching to a mid-inclination orbit and filling the gaps for our customers that wish to expand their coverage or complete unique objectives that aren't possible with sun-synchronous orbit. It's a little dark out, but you can see the silhouette of the grid fins. Falcon 9 is equipped with 4 hypersonic grid fins positioned near the top of the first stage that help steer the first stage as it returns to Earth. We're about 20 seconds away from the beginning of the entry burn.
Stage 1 entry burn startup.
There's the callout for entry burn startup on the Falcon 9 first stage. This burn is set to last about 20 seconds.
Stage 2 FTS has saved.
And again is slowing down the vehicle in preparation for its final burn and landing.
Stage 1 entry burn shutdown.
And that concludes our entry burn. The first stage has
Both trajectories are nominal.
The first stage has one more burn left to prep for landing. And as mentioned earlier, we will be attempting to recover this booster, targeting a landing at landing zone 2, which is not far from our launch pad. The Falcon 9 first stage is equipped with 4 landing legs made of carbon fiber with aluminum honeycomb. Placed symmetrically around the base of the rocket,
Stage 1 FTS has saved.
They'll deploy just prior to landing.
Stage 1 transonic.
Coming up within the next 18 seconds, we'll have the start of the landing burn of the first stage. The landing burn is the final burn of the Falcon 9 booster, used to reduce the remaining speed of the vehicle for a gentle and precise landing.
Stage 1 landing burn.
And there you heard that call out for the landing burn start on the Falcon 9 first stage. This is the final burn that this booster will see before touching down on landing zone 2.
Landing leg deploy. Stage 1 landing confirmed.
And there we have it, another successful first stage landing at landing zone 2, marking the 3rd landing for this specific booster. Now we have about 2 minutes remaining before the next event, which is SECO 1, or Second Engine Cutoff 1. That's the first of 3 planned events where the second stage Merlin vacuum engine shuts down and restarts after a coast period. Again, we'll do this 3 times before all payloads are deployed.